Welcome. This video is a continuation of the previous video for those of you in my calculus course, or can be watched as a standalone video. What we want to do here is we want to find the equations of the lines tangent to F, and here I've written down F, that are parallel to this line, x minus y equals 3. So one thing to remember is parallel. That tells us the lines have to have the same slope. And what is the slope of this line? Well, the slope of this line is 1. This can be rewritten as y equals x minus 3. The coefficient multiplied to the x is 1. That tells me that the slope, I'll call that m, is equal to 1. So with that, recall that the derivative function gives you the slope of this curve for any x value. So all I need to do is set this derivative function equal to 1, and then I'll find whatever point or points are parallel, that is, have a slope of 1. All right, so 1 is equal to 1 over x plus 1 quantity squared. So that is x plus 1 quantity squared is equal to 1, or x squared plus 2x plus 1 is equal to 1. Or x squared plus 2x is equal to 0. And that tells me that x times x plus 2 is equal to 0. Now, if you struggled with the algebra here, please, you need to pause the video and redo this whole portion that I have, kind of circled in this red laser pen. Please redo that if you at all struggled with following along with that algebra. Okay, so that aside, x equals 0 and x equals negative 2. So let's now remember the point slope form of a linear equation. That's y minus y naught is equal to m times x minus x naught. We're going to use that. So our x naughts are here. This is one of them, this is the other. So we have to figure out what y naught is. Well, let's begin with the x naught equals 0 case. So when x naught equals 0, y naught is equal to f of 0 is equal to negative 1 over 1 is just negative 1. So y minus negative 1 equals 1 times x minus 0, or y plus 1 equals x, or y equals x minus 1. So I know that this line here, certainly just by looking at this, shares the same slope here as this equation, y equals x minus 3. And we are certain also that it is tangent to this line at that point, 0, x equals 0. All right, so now let's look at the case where x naught is equal to negative 2. So when x naught is equal to negative 2, y naught is equal to f of negative 2 is equal to negative 1 over negative 2 plus 1 is equal to 1. So y minus 1 is equal. All right, so then y minus 1 is equal to 1 times x minus negative 2. So y minus 1 is equal to x plus 2, or y is equal to x plus 3. And here is our other tangent line that we're going to look at. Now, when I said look at, I literally mean look at. I think a lot of this can be understood so much better if we can see a graph of it. So please open up your favorite web browser and go to GeoGebra. And once you're there, you don't need to sign in, but you do need to click on this grid here. And I prefer to use Classic, so go to GeoGebra Classic. And let's go ahead and type in f of x. Well, f of x is equal to negative 1 over x plus 1. There it is. And now we were interested in tangent lines parallel to x minus y equals 3, which we rewrote also as y equals x minus 3. So let's type that one in, y equals x minus 3. And as you can see, they're the same line. You can hide them and show them. They're the same line. So I'll leave this one out. And now let's type in our first tangent. I'm going to call this tangent 1 of x. That's equal to x minus 1. And there is that first tangent line in red, and it certainly looks parallel to this other line, y equals x minus 3. Now let's go ahead and look at tangent 2. So big T underscore 2 of x is equal to x plus 3. And there it is. There's that other tangent line in blue, and certainly visually we can see that these are all parallel to the line here in black, which is y equals x minus 3.